Good evening and welcome to Wednesday streaming. It's creative night. We're doing a bit of creative stuff this evening, so a bit of design, crafting, music, that kind of stuff that we were doing. Oh, there's some sort of bugger all viewers at the moment. Typical. But we'll see what I think. Hopefully, we'll join in as we go. I'll give it a few minutes and I'll go through basically everything to do and see. Yeah, so I hope everyone's had a good week, had a good weekend last weekend, and had a bit of fun. It's been an interesting week for me, a busy one. Tried to do some diagnostics on why I was missing frames on Sunday's stream of the RPG as badly as it was, but honestly have no clue. So not entirely sure what's going on there. So I'm hoping that things are going to be good for the sound this evening. I'm using something a little bit different. You may have noticed that with the little intro we had there. So yeah, we're doing creative this week. Now, what I've thought we'll do is we shall. Oh, good God, man! Gotta stop that. Gardini, good evening to you. Yeah, so as I was saying, the creative idea this week is we're going to go through the fundamentals of 3D printing and 3D printing design. So essentially, 3D printing and 3D design are two elements that kind of fall in together. So anyone who's familiar with software like 3D Studio or going in and out a bit, not sure why, it should be okay. I'm going through a filter because I've set up some filter software. Doing something a little bit odd with the music this week. So just let me pop some.
Helium, that makes everything just so much better when you put helium.
And we have a lovely singing voice with my chorus of you again. Yeah, when I put the filters off, it seems to drop out a little bit. I'm not sure why, but the pickup seems to be okay. But we'll see how it goes. If it turns out it's going to be a bit of shit, then we'll flip back to the ordinary stuff. Anyway, so how are things going? Yeah, so what we're doing is we're doing some 3D stuff. The plan is I'll take a look at how you set things up for 3D printing in terms of designing your own model. Now I know there's a lot of things out there that you can download for 3D printing, but you also have the option very, very easily using various bits of free software to design your own 3D printed objects. But there are some things that you have to do in terms of your design and your development of that design to make sure that things print off properly and that you don't have any issues with it. And so that you can use the minimum of what we'll call supports, that's what they're called, as you print. So therefore you're wasting as little plastic as possible and being all kinds of eco-friendly. So, anyway. Alright, so the fundamentals are, let's pop over to our gaming stream layout and have a look at where we are. Now, I've had some issues with trying to get this all set up today. Because it's just a little bit weird trying to get this thing set up properly to work. But trying to get it as good as possible, set up as accurately as possible to run well. So, let's just minimize that out of the way for the moment. Right, well, okay, so the first thing you need to do, if you want to design something for a 3D print job, you need some kind of 3D design software. Now, the one I have used for years and years and years, and people who know me from the Uleek forums many, many moons ago will remember I used to do some modelling for that as well. Now, I've been into 3D design since I was, 2021? So like 20 odd years it's been anyway, since I had a PC powerful enough to do it. I've been into graphic design since I got my first Amiga, which was 93, 91, 93, something like that. And my first dabblings with 3D Studio, with Deluxe Paint. 3D was where I really wanted to do some work. And it is a bit of a dream of mine to become a graphic designer or a 3D designer. Whether I've got the talent to do that, I don't. We'll see. I've been doing this for a while, but I know for a fact I haven't got the hang of all the basics in it. But we'll see where things go. So, I use this application. It's free, it's easy, it's very, very simple to learn. It's called Wings 3D. So if you want to have a look at wings3d.com, I think it is, you can download this software for free. Now, the reason I use it is it's a subdivision modeler, which means you essentially create a simple object and then you sculpt that object to create whatever it is you want to print, whatever it is you want to design. It's fairly easy to use. It's much better than your than other sorts of modelers that I've used. I've tried to use Blender and I cannot get into the user interface for it. I do want to use Blender and it is in my to-do list to learn how to use that software properly. But we'll see how things go. I'm not great at it. I'm great with it at the moment. We'll see how things go then. Right, so in terms of how you want to design your 3D model. Now what you're looking at here on your thing there is that grid represents your gravitational plane. So in terms of this development software, it's your y-axis. So you're up and down. That represents, in 3D printing world, that represents gravity. So gravity is going down this plane. So everything will go down towards that grid from there. Anything that you've got underneath that plane will be traveling upwards towards it. But so anything you print below that is not going to work. So essentially, what you need to think of this grid being is your print plate. Now, print plate is on your 3D printer. You have a plate. I'll show you it. This is your print plate. Now that sits on your 3D printer, and your print is drawn on top of that. So that's where it's drawn. That represents essentially what you've got on the screen. Okay, so again, if anybody has any questions, if anybody's in chat, I know you're still there, Gareth, then feel free to pop anything in. So, anything you print, anything you design that has to come onto there is going to be drawn down to that plane. So 3D printing essentially creates layers. So what you do is you're creating a layer on there. You create a layer, draws your plastic thing, and then it moves up a little, and then draws another one, and then draws up a little, draws another one, up a little, draws another one. So it creates it in layers. So what you have to make sure is that each layer can be easily deposited on top of the one below. So what you're looking at is something that you can print on the vertical so that gravity will assist you in your actual printing process. That's the tricky part. So obviously most 3D objects you're looking at overhangs and slopes and slants and all that kind of stuff. So all that has to be taken into account. There are various ways of doing this. The initial one is to try and develop something or design something that you can put into place that is only a vertical. So for example, we create a cube. Now as I said, your cube, as it comes on here, is that, to 3D print that, you would have an error because your bottom is below the plane where you want to print. So as you can see, that is halfway through. So what you need to do those situations where I'm not in the right mode. Sorry. So you grab your buttons and you move them. So this line here where it shows you the aptitudes, that's always on the zero level. If I highlight that, you'll see up in the top there where it says there, that's your position. So that's your X position, your Y position, your Z position, or your Z position for you American people. Importantly, when you're 3D printing, your bottom layer or the bottom of your model has to be at 0. So that's the plate. That's your print plate. Is at 0. Okay. So what you've got there is a plain cube. Now, obviously, what you would see is if I split this up into that. Now, that kind of simulates how your print is actually made. So this bit here along the bottom, that's layer 1. So that's the first layer that your printer will deposit onto the plate, and then once that's done, it'll lay the next one down, then the next one, then the next one, then the next. Okay. So as I say, you're trying to make it so that it's easy to stack these layers on top of each other without any issues. Now, another thing to think of is, especially if you're using solid objects like this, if we undo those layers, I go back into the model and make it back into a cube. Up one, so that's back into being a cube. So for example, if you're wanting to use this, like a basic cube model, you can use to make a dice, 6-sided dice. To do that, obviously, you would make sure that your block is solid. You don't have any overhangs or edges on it, and something like a poker die, for example, is sharp-edged, sharp-cornered, and you don't have to make any modifications. So all you need to do essentially is to make your dice, your numbers. Sorry. Now I can show you that very quickly here. We'll just do a few cuts, and then we'll do that, and then we'll do circular eyes, and then we will do that, and then extrude that down. There you go. A very, very simple base for a die. Now you can make it a little bit tidier. For the sake of this demonstration, I'll do this very quickly. I'll explain what I'm doing in a second. So what you've got there is you have a tessellated and triangulated shape that will 3D print easily. Your hole is in the vertical, so you're okay with the way it prints. So you're okay. Now, small details like that hole that I made are easy enough to make. The 3D printer's resolution will be 0.2 millimeters per layer, and probably about 0.5 millimeters sort of on your Z and X. So when the print head lobs down a layer, when it lays it down, it's about 0.2 millimeters. Although it can splooge out a little bit depending on your settings and your alignment. So essentially what you're looking for is trying to print something that is going to print easily, and gravity is going to help it stick to the plates. So if we just have a look at easy to print shapes, if I scale that, that's an easy to print shape because that shape is completely tapered. So obviously all your stacks are going to be stacked smaller than the rest, than the next one on the bottom. So that's easy enough to do. However, that would be problematic because each layer is actually stuck out a little bit over the edge of the first layer. So if I do what I did last time and chop that up into sample layers, as you can see, you've got an overhang there. So that's not exactly how it would print, because what would generally happen is you would have like a stepped pyramid more than anything else. So it would be at right angles. So it would go because it can't print slants. Because you've got 0.2 millimeters, it's a very fine resolution. So what you'll find is, because your splodgy layer is about 0.2 millimeters, your resolution of your actual movement of the print head is less than that and can be anything down to 0.01 millimeters. So you can overlay. So what you'll have is, what you would have within each of these is a very, very small overlap on each layer. Trying to show you that is going to be quite difficult. But anyway, you get the point. I'm hoping. So if we come back out of that again, go back to our cube. The other thing to take into account when you're designing a 3D printed model is how you're going to fill that model up. Now, obviously, the default you would assume here is that is just one block. What you can do is you can have the box completely filled. So plastic all the way through, 100% plastic all the way through. Or you can put gaps in. Now, these are called infill percentages. Now that means that when there isn't a layer, or an edge, or an end, or a face, within the model itself, it would be kind of hollowed out. Now you can have a lot of different ways of doing this. You can have a honeycomb pattern, or you can have a square pattern, or you can have something like that. I'll show you that once we get to the 3D printing side of it. You don't have to worry about that too much in terms of your original model design. The only thing you have to worry about is how easy it's going to be to ensure that you can use as little plastic as possible, while making sure that your model is fit for purpose. So you want to use your model for something practical, and you're going to be using it to apply pressure to something. Like, for example, if you're going to create a plastic knife for cutting boxes, which a lot of people do, you can create box cutter, but have back knife. So, and you can create quite a fine edge. It works quite well, but you need to make sure that that is not too brittle, or will basically just fold and snap if it's all the way inside. But for something like that, you need to make sure that it's 100% filled. So, simple things to print. Now, anything, as I said, that is a simple shape like that is fine. Now, for example, one thing I have printed before is a lightsaber. So if I do a cylinder, now you can do this. There's your cylinder. As you can see, that would be easy enough to print. Could load in a model I already have and show you how it works. So let's do that. Let's have a look at lightsabers, Lego saber. Okay, so that is the Lego lightsaber. Render that fully so you can see it. Now that is rendered into many individual parts. So each of those is easy enough to print on its own. So we have this part here, which is a hollow torus, a hollow cylinder. That'll print on its own. You then have a filled in cylinder with a hole in the middle. Also print easily on its own. You have this bit, which will print easy on its own, because it has the solid base around there. And you have again all these different parts here, leading up to the top. So everything is stacked against each other. If I was printing that all in one go, then this bit here would overhang this bit by a huge amount. Now there is a percentage of how much you can do. So if you have a slope of 45 degrees or more than 45 degrees, then the printer will struggle to handle that. If your slope angle is 45 degrees or less, then there is enough of an overlap in the plastic layers for it to actually dry quickly enough on the overhang to not have a problem with drooping or being pulled down by gravity. Because gravity is not strong enough for the 0.05 millimeter overhang to drag it down on each layer. As your layers sort of go more of an angle, then they have to be offset that little bit more. If you look at where my fingers are in relation to each other there. Yeah. Let's use something. Let's use phones. Right, so there's 2 layers. Okay, so that's 2 layers there. So they would sit on top of each other. If you have a small angle, so say that as the cross section of the layer. So you say that is essentially 0.2 millimeters, and that's 0.2 millimeters as well. What will happen is you'll have, as your slope increases, each layer as it's deposited down will hang over further. And once you've got to about 45-degree angle, you get to about there. So half of your layer is sitting on top of the other, of the layer below. And then the more it goes, the more it's liable to tip over, as you can see just with gravity here on the board. So that's what you have to be careful. Your angle is dependent on the width of your nozzle. So if you have a 0.4 mil nozzle, then you have 0.2 millimeter of play on each incremental layer. There's a lot to think about. So, other models that we have, I mean, I've got quite a few models here. So as you can see, if I load up that one, or not, let's load up Hexby Castle. That's quite an interesting model to look at. It's a very simple model because essentially, again, it stacks. So you have each element of the design has been made so that it's easy to print in 3D. So your turret top, which you would sit on top of there, is printed as a separate part which sits on top once you've actually built it. Now, if I try to print that with its flat bottom, which hangs over quite a bit, and if I move that on top of it, I can maybe show you. Move 3. Let's do that for the sake of argument. Okay, so that, as you can see, that sits on top of that tower very well. But you have a 90-degree angle there. So you have your edge right on that bit where it just hangs over and it's flat. So it goes up and it goes across. That would overhang too much because that's going to try and print that entire bit, which you could say, depending on the scale, could be anything up to a millimeter, 2 millimeters. It's going to try and lay each of those. So if you're looking at a 0.2 millimeter nozzle, if you're trying to lay down 2 millimeters, it needs to lay down 10 millimeters. I think that's right. 10 layers to get from that edge there all the way out, and that's not going to hold up because it won't have anything to build on top of, so it'll just fall. So you're basically printing into the air, and then it will fall down, and it'll be all horrible and stringy and hopeless. So that won't. Hence why the model has been designed to print off like that. So all the larger pieces are on the ground or on the print plate. No droopage, no overhangs, everything is okay on the vertical surface to print. Okay. Shall I have a look at something else? Those are paper models. This is basically an idea for not particularly complex model. This is just a proof of concept, really. This one, but essentially, what it is, there's fucking dogs going again, as always, every fucking night, all day today. They've been going on. Bastards. Simple idea again. But this actually shows that you can actually print off separate model items. I only seem to be playing Elite Dangerous songs today. Yeah, when you're 3D printing, you can, although it's quicker and easier for the print processing to take a single model, which has been combined, you can, in theory, print off a model on the printer that is made up of lots of different objects. It will take longer for it to process how to cut them all into layers, which I'll show you shortly. But essentially, you can do pretty much anything. It's pretty versatile, this 3D printing. Lego pistol, that's something to know. Now this is a scaled up 1-to-1 human version of a Lego pistol. So again, this illustrates how you can break up a model to print it off in easy sections. So the whole model being put together would have hollow bits inside, it would have overhangs, you would have these bits would all be stuck together, and you'd have so many vertical droppings, and also you'd have no way of standing it up. You turn it on its side like that, but again you're going to have this, the cylinder is going to be lying on their side, and you'll have a flat spot at the bottom, like you would with a tyre if it was sitting on the ground, because you are obviously printing warm plastic, hot plastic. So breaking it up into these individual component parts means that you can import each individual part separately onto the print plate. You can even do loads at a time. You can do 1 or 2 at a time, depending on how large your print plate is and how big your parts are. So, yeah. Again, as you can see, each individual part there, that bit in the middle there is just the print plate area. Each bit has been designed to be printed on. So the trigger part there, this part, we print off with this bit at the bottom. So that's the bit. That's the face that would sit on the print plate. With this piece, it'd be this edge that would sit on the print plate. With this part, it's this bit that sits on the print plate. But again, remember we talked earlier about the angles. That angle is less than 45 degrees, so that angle is enough to be able to print. But having said that, this bottom angle is also at an angle. This bottom face is also at an angle, so it's actually more or less straight. But you have an angle there as well. So these bits, that bit and that bit, that prints off the same way it is, because as you can see, you've got the angle going sloping towards the top, sloping in towards the top. This one is printed the other way up, so it's printed upside down, so you've got the angle the other way up. And obviously all the cylinders are printed on their end, so end first. These inner bits here have been designed so that they can be printed on their on this face, so that there are no vertical things there. Now, you could, in theory, print some of this stuff normally as a single object by using supports. Now, I'll show you supports hopefully a bit later on. So, at this point, there don't seem to be a lot of people actually watching the video. So, if Garzini has any questions, then by all means fire up. What I was going to do was take a look at actually designing a little object just to have a test print of, so that I can show you how the layering works and how it puts all these things together. So what I'll do, ask it for some kind of idea what to print, essentially. I'll have a drink while I'm at it. Pardon me. Cool. Fair enough. So it does kind of give me somewhere to go. So what I need to work out is how I can. Things we have to think about. I was kind of expecting more people on at this point, to be honest. Hopefully a couple of questions and a couple of ideas. but I'll just bring it all up on my own now. One of the common things people tend to do is look at things like logos. If they've designed a logo for something, or they've designed a mark that they want to use, or a button, or a gaming piece, or something like that, then it's something that's quite useful to do. What I'm going to do is I'm going to default to one of my usual things that I tend to do. Now, I started off this whole streaming lark as an Elite streamer, so let's have a look at a model from Elite and try and print that in 3D. So I'm going to go for the old style Sidewinder, which is a very simple shape to make and a very simple shape to design. It's a triangle with another triangle coming off it and a triangle at the back. So if I draw it as it would be in the actual game, now essentially what we do, most things I do is I start off with a cube. So there's our, I'll go into that mode, so we're flat, or orthogonal. Orthogonal is it? And we'll move that up to 0. So what we want to do is make this into a Sidewinder mode. Now, to do that, scale uniform. No, scale radial here does it across a radial distance. So I'm going to make that bigger by 1000%. That makes it. Now, each of these boxes is one unit in this thing. The main scaling option by default is that a unit in Wings 3D is a millimeter in real life. So each of those is a millimeter. So that now is 20 millimeters. That's 2 centimeters in length. Or 2 centimeters square. And about a millimeter high. So what I want to do, I'm going to bring that up to make it about 4 millimeters. We don't want it to be totally square, so we'll move that back by 8. So that's 12 millimeters. I'm going to move that to the center. Hold that active. So that approximately. Right, now what I'm going to do, I'm going to drop that down another 2. I want my Sidewinders to be sleek. Now essentially, looking at it from the top, select edges. Now we know that we have 3 triangles, so it needs to go like that, and then out there. So we need to chop that front edge into 3. So I select that and then press T on the keyboard, which splits it. We then have to grab those corners and join them all together. Pressing C once you've got dots or vertices selected, joins them up like so. So you can see we've got our basic Sidewinder shape is starting to come out there already. If I just delete those by pressing delete. Oops. Okay, that brings us down to there. Now, we know that the triangle from the front here goes to there. As you can see, we still haven't quite got the right ratio size per side. We're going to move that forward another bit. 3, that will look about right. So then we need to, I'm going to press select those edges and I'm going to press 2 to chop that up. And then I'm going to pick these vertices there, which all need to join together. And that will also put a cross up there, which I don't really want. I'm going to do it anyway. So that joins all together. And I can select that and delete it. There we are. There's our initial look at this. I'm going to scale that across on the x-axis to try and equalize those triangles. More or less accurate. That's about right. What we're looking for is roughly 3 isosceles from. That's close enough. Right. So again, what we're looking at is we have to have that taper. So again, I'm going to select all those edges. Again, you can group select by dragging and doing that. If you manage to, you have to select your option there, not which one. So I'm going to join all those together and create, like, I'm going to split them all in half then join them all by using the C key, which is C for connect. There we go. That's created a median line across the center. Now from here, it's not that hard to actually turn it into a proper looking sidewinder. I'm just trying to get rid of that plate because all we need to do is bring that down into a slope there, and there, making the triangle that we all know and love. I'm going to do that by selecting all those vertices at the back and joining them together. And then I'm going to remove the inner part. So there you can see the back end of the Sidewinder. And again, remember this is the classic Sidewinder from Elite/Elite. So the old boxy triangle design that everyone kind of got used to. Now what we need is that then to slope down to the front. We need to get rid of this vertex, these vertices here. 3D design, if you don't know, you have three objects. You have three types of objects you have to worry about. You have vertices, which are these dots on the corner, so where all these edges meet. You have edges for those, and you have faces for those. Now, each vertex is where edges join. Every edge is made of every face is made of at least three vertices. So triangulation is a big thing in 3D modeling, and in this is no exception. As I said, we want to pick those vertices and then delete them. Now it's looking like a sidewinder, isn't it? So that brings us down there. So we need to get rid of that, and that. And then lo and behold, almost we have a sidewinder. Now sometimes this application loses edges. So what you have to do is make sure you create the edges back again. And there you have it. There you have the original design Sidewinder. 6 triangles stuck together with a triangle on the back. And I show you the insetto. That's how you make your engine. So there's your engine. You can scale that on the y-axis. Nope, that was the wrong axis. Scale by make. So there you go. That is more or less your model. But as you can see, the problem we have is that there are no supports under there. That's not going to sit because that's your print plate across this plane here. You can't print that because it's going to overhang too much. That will just drop onto the ground and you won't be very good. So we need to find some way of making that printable. So how do we make something like that easily printable in 3D? So the easy way is to rotate it. So I'm going to rotate it along the x-axis. I'm going to do it. In this case, I'm going to do it around the center point of the draw, because it makes sure that it moves it. Okay, so that moves that there. So now that puts it on its end, so that all the gravity is going to draw that bottom face onto the ground. So that all your weight is going to sit on top of that, and it's going to be nice and level. So what I'm going to do here is just check that's at the zero. So yeah, that's at -3. So what I need to do is move that up 3. So up 3 on the Y. And I'm just going to center it. So that centers it. That's putting it on the ground. That's sitting properly on the print plate. And you can print that easy as pie. That's the easiest model you could ever wish to print. Similarly, with the Cobra Mark III, you can do the same thing. So let's move that out of the way for a second. So let's hide it. Select. Hide select object. If we drew another view, go through the same rigmarole again. I've moved it this time. Scale, radial, height. Okay, that's approximately Cobra. So again, what we're looking at is making the shape of the ship that we all remember from our childhood. I'm going to chop that in the middle. I'm going to move that out of the way so we can see more clearly. We know that the good old Cobra has the triangle at the front. So again, that was just highlight all the edges and then press C to connect everything together on that middle layer. And then we know we have the bottom edge. Again, we need to chop that in too. So we've got approximately this end. So we know that the front edge you have the triangle that goes there, and then you have the line back. So we know we have a center line at the front. So select that and press 2, and that gives us our center divider. Now, we do know from the shape of the Cobra that this goes back about halfway. The triangle goes back to there, then to there, and we have a line that goes to the middle point that we created earlier. So in order to create that center line, we'll select those two. As you can see, they're both selected in red, and then connect them. And that brings us our midpoint, and then we can press 2 to give us a central point there. So with that, if we join those two together, and then we join that to there, you can see the shape of the Cobra starting to come out. Now, these two dots are now not quite right. So we know we have to kind of mirror what's happening all the way through the rest of the shape. So we'll chop those in two as well and connect them for now. I want to get rid of that. And what we want to do is move those back a little. We'll put them back there. So as you can see, we've got the approximate shape of the top of the Cobra coming out there. We know there's a slope there, so let's put that slope in. And we have the same slope there as well on the side of the shape. Joining all these lines together gives us the rough idea what the shape is going to look like. Okay. Start to see the shape coming out there. That's fine. That's correct. That's exactly right, Garcia. Glad somebody's here, to be honest. Fine, nip them out of the way. That gives us approximately our Cobra shape. 3 points on a triangle is also why most of the elite ships were triangles in the first place. It's much easier to render a triangle than just to render around a because you have to make sure it's just the minimum amount of points and the minimum amount of edges that have to be calculated in 3D space, he says. So let's try making the Cobra shape. We'll pull that down there. We'll pull that way. Also, what I'm doing there is I'm making multiple cuts, and then I'm just going to keep the ones I want to keep. So those. There's your Cobra shape. We'll just join those last two together. There's your Cobra. Make it right. Okay, so that's roughly what your Cobra look like. There you go, one Cobra. There you go. An approximate Cobra shape. It's not perfect. It's not 100% canon, but that's roughly what it looks like. So again, we're looking at this and we're seeing we're looking at this and we're seeing again that we have this overhang here. But again, with this model, it's easy. We have a flat plane on the on the back there, so we can do the same as we did with the Cobra, the side bumper, and we can rotate it on the x-axis 90 degrees. I'm going to do that on that. So rotate x middle button is the origin point. Okay. Now as you can see, that's actually not quite that. That's actually gone a bit further down than what I intended because I rescaled it. So you can make it get it as close as you can. To that 0 level. As you can see there, that is almost exactly. So it's 0.0003 of a millimeter. So essentially, I'll just move out the loop. I'll put that to 0. Right, so there you go. That is now a 3D printable model of a Cobra. Other way you could do that with this one, is you can use this edge, this long edge, if you're flat. But again, you've got this overhang here. It's going to cause you problems. So having that back edge is what you would need. But the other thing you can do is you can split the model up. And principally, say you've got a model that isn't easily liable down on a flat edge. As easy as this model is. So say you don't have that back edge. Let's create a brand new shape by morphing this, if I can remember how. Use the points, form, taper on Z. Deform, taper, okay, so now we have a shape that doesn't have any flat area. So this is the Cobra Mark 5. No flat area at all that would allow you to set it down and print it. So what can you do? What can you do in this kind of situation? Well, let's do something else a bit weird as well. Make it all kinds of fun. The smoothing thing in wings isn't good. as you can see, that is a model that is not going to sit happily on anyone's print bed. But what we can do... Grumtastic! Hello! How are you doing, sir? Thank you for watching. So what can we do with it? Well, whereas before we had a load of triangles, this doesn't have triangles. So what I'll show you at the moment is to get around some of the problems that we have with the render and the shape of the object and how to print. As Garzini mentioned earlier, 3 points in a triangle give a flat plane. Everything has to be in a flat plane. So if you're trying to print something off in the real world, you'll be looking at as simple an option as you can get. Now what you have to look at is each time the print slicer tries to calculate how to print the shape off, it has to calculate all of the edges, vertices and faces and make sure where they are in relation to each other. So it has to do all that calculation itself. If the model itself has already been triangulated and each face is a triangle, it saves a hell of a lot. So we can do that in Wing with most other projects as well, by going to the right click menu, tessellate, triangle. Now that sorts all of your things into triangle. So everything now is a triangle. Sometimes it doesn't do it particularly logically. For example, that line there, I wouldn't put because that makes a recess. I prefer to have sticky out. So that makes it slightly better. Again, there. That'll be difficult to print in anyway. So a lot of this comes down to your eyes as well. So what do you think would be easy to print? How do you think it should look? What makes it more obvious to you? To me, that actually looks like it should be there. That's, the smoothing has not done a good job of making that. So that seems that much. And again, I'd say the same there. Look at that. That's they did before. Those and that are extraneous. That and that don't really need them. That and that don't really need them. Down here we've got that one and that one, that one. A bit of clean up, just make it look a bit more sensible. And again, you can tessellate yourself manually by doing all that. There you go. That looks like a reasonable model. Now that, as I said, will not 3D print particularly well. There are no flat surfaces. There's no way you can sit it on its end and print it off on a print bed. It will not lie flat. It's not looking great at all. So what you can do is you can use supports. Now, what I'll do is I'm going to save that one. No, it's a broken Cobra Grumtastic. So I'm going to go into my model. I'm going to go to new folder. Eventually, 3E tutorial. So that saves that model as. We'll come back to that later. Now we can print that off by using supports. What supports will do, we bring back our plate again. See, this is your side view, so this is your bottom face. Move that. Just put it. What supports will do is they will actually take that model and they will add a supporting brace across all of the overhang bits. So all those bits under there, they'll have a support plastic made of, and obviously all those overhangs here. That bit will sit flat on the ground, and these bits will have supports underneath them that you can then break off or melt off. Supports are tricky, so you have to have them set exactly right or they won't work. But what we can do what I'm going to do is I'm going to actually export them. So I'm going to export, and I'll show you. This is how you do the 3D object print off on a 3D printer. The wings format, where you've got Cobra broken.wings, that is a proprietary format. The OBJ, or objective format, is one that is used by default everywhere. It's just a text file that can be interpreted by a lot of different things. Printers use G code, 3D printers use G code, and they can convert an OBJ file into G code very easily. So what we have to do is we export selected, which will export it on the flat plane anyway, in wavefront OBJ, Cobra broken. Okay, that's that. So if we wanted to use another method, we can go down the route of trying to chop this up into something that's 3D printable. Now, the easy option here is to cut it down a line in half. Now we can do that in the centre line quite easily. So if I grab the obvious places, so we have a dot at the end, we have a vertex there, vertex there, and on the underside we have the same, we have some vertices across the front. What we need to do is make a break here, here, and here. Now that's all the bits we need to break in order to have a centre line we can use. So if I chop them by pressing 2, you can see they're all broken. I then click on the vertex and join it there, and then do that. Then you can see we have a centre line. Now I can use select one line on one edge, and then press L, and it will loop all the way around. That's what's called a loop, and it's created a loop. Now what we can do then is do a loop. So if I then go to that, we now have two separate objects. What I'll do is I'll move them forward slightly across on the X. This will let you see in between each object. So there you go, completely flat clip, which you can then tessellate. Right, that's that now tessellated, ready to print. So what we can do is we will rotate them around on the Z axis. Y. Remember again, we need to put them on the baseline. Right, there's our two halves of shape. Deselect them. We can now print them off, and we could, in fact, we could print them off and together and stick them together. So if I select them both, export selected, wavefront, Cobra broken arms, OBJs. There we go. Right, so that you can print them off because they will both sit on the print bed, and we can print them off at the same time. And they will build the same model that we would have with the other. See, that's what Garzini said as well. I'll tell you what I'll do. Tell you what, hang on. Let's skip all the fancy dandy shit what we're trying to do. So I'm going to go there, and then go there, apply. Is that better? I should keep it a little more constant now. I'm using a voice filter. Obviously I need to do some more setup on it to make it pick me up a little better, but we'll sort that out next time. I'll just close that up. I'm not going to use it for the rest of the thing anyway. That should be okay now. Okay, so that's that. So let's hope that we can now go. I'm going to undo everything I've just done. Take it back to the original Cobra model. not enough undo steps. That's bloody typical. But anyway, we don't really need that. I'm going to get rid of that, and we'll bring back the Sidewinder. So let's bring back the Sidewinder. Select, unhide all objects. So there's our Sidewinder that we had earlier in the show. Now we can just export that, and that'll print off exactly as it should be on that angle. So I'm going to select that, export selected, wavefront, Sidewinder. Now you can do anything you like to that model, as long as you don't screw up that back edge, and you can make it as detailed as you want to make it. Now I would quite like, for example, to do some of the cool stuff that they did with the new Sidewinder, so I am gonna muck about a little bit with it and make it cool. Do 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 do. Flatten Z. Move Y. Oops, nope. Move Z. So you can make a pretty cool looking shape just by mucking about with a few of the basic shapes that you can have in these things. So I'm going to grab them as well, get rid of them. There you go, slightly more up-to-date Sidewinder. I quite like that. Huh. What do you know? What you can do is just a bit of faffing about. Right, so let's export that model. Let's export selected. Sidewinder modified. But again, we've done all that modification, all that mucking about, but retained that flat back edge so that we still retain our ability to print that in one block. Okay, so we have that. Right, so next stage is we take a look at what we can do with this bit of software. Now this is matter control. The printer I have is the Vector 3 printer, which came as a magazine gift. Not a gift as such, but a thing. Grab the camera and let you see it a bit more fully. Try and point it in the right place. That's it there, that white thing next to the halo. This. That's the printer. You've probably seen it before in a few of the other things I've done. But if you want to look it up, if you have a look for Vector 3 3D printer online, it'll show you. It was an Eagle Moss partwork series that came out over a couple of years. Ended up being roughly 700 quid to buy, which is roughly what 3D printers retailed for about the time. They've, since that magazine stopped being published and since I built this printer, they've come down a hell of a lot, 3D printers. But at the time, 700 quid was about average for a decent home 3D printer. And it is good. It has its shortfalls. It's exactly what it is. It's a middle range 3D printer for hobbyists and home users. It's not professional by any way, shape or form. But it works. So the software that comes with it isn't particularly versatile. It comes with its own proprietary thing, and it's not great. Matter Hackers gives you more control over the actual software itself and more control over the actual printer's hardware setup. It gives you a much more easy to use balancing configuration for the print plate. So rather than having to muck about with screws and screwdrivers, all you have to do is just do some tests on it with bits of paper, and it'll let you balance your plate properly so that everything's flat. And it has more options in it. So, and it's got better user interface as well. That's not to say that the one that comes with it is crap. By in no way, shape or form is it crap. It does the job. It's just not particularly advanced. So what we'll do is, right, once you've got your 3D object done, you need to import it into a slicing software, which will let you modify it. So what we'll do is we'll add one in. Let's have a look. So let's nip onto my hard drive, into my secret folder. It's not all that secret. 3D models, my models. Where is it? Where did I put it? Printing tutorial. There it is. Oh, hell is bastards! I used the wrong bloody format. Okay, I'm wrong. It's not it's STL that you need. Not OBJ. STL. You twat. Export selected. Stereolithography. Sidewinder. Save. Right, if I then hide that, hide selected, file, import, oh no, that one, file, so it, file, import, OBJ, bring in the visual sidewinder, select it, export selected, stereolithography, save, delete, file, import, OBJ, Cobra broken, file, export selected, stereolithography, save, get rid of that, file, import, Cobra broken halves, boop, boop. Stop that. Export selected, lithography, Cobra broken, halves. Save. Medium range software, medium range device. Yeah, pretty much. Yeah, it's mediocre software. I would say it's mediocre software for a half decent printer. It's not a bad printer. I mean, for essentially paying for it 10 quid a month for 2 years and then building it myself, it's bloody good. Especially given the fact that I didn't build it myself. Okay, so that's fixed that again. Right, let's go back into to thingy now. Right, so there we go, we have it there now. So let's load up our Sidewinder. Okay. The jerkiness on the screen, by the way, isn't anything to do with the driver. It's to do with the way I'm linking to this application. Okay, so we can use that software to scoot around the model, and there we have it. Right, that's it sitting on the print plate. This is a rendering of the print plate on my printer, which is 12 by 12 centimeters, and as you can see, that model is about 2 centimeters across, roughly, which is what I said it was at the start of the thing. And that's how it'll print off. That's the orientation, so that's all right. So what we need to do is we need to look at how to break it up and how to print it off. Now we can look at the layer view and generate. What that'll do is it'll use the pre-generated options to break it into layers. Now that will show you how it works. Now that, around there you've got 2 lines. Those are your lines of plastic. And as you can see, there's your first layer of your actual model. Now those are rendered completely as blobs of plastic, but in the real world your hot plastic will melt down and it'll be slightly less round than that. It won't be, if it is that round, then your print plate is too cold. And using this software, which you can't do in the software that came with it, you can build up the layers on the screen and see how it goes together. So you can see what I mean there about how your layers stack on top of each other. So if I zoom in a bit, you can see that there's that incremental stepping. This was right at the very start of the video, Grumtastic, so you missed that bit of it, I'm afraid. But you've got the incremental step in there to show you where each layer of plastic sits on top of the previous one. Actually doesn't look right. What the hell is going on there? Import STL Sidewinder. Oh, that's a bizarre thing. Yeah, so for some reason it's got a bit of a pop out at the top there, which is odd. Shouldn't be doing that. That might be an import error due to the size. And this is what I mean about the way that sometimes these things work. You've got to think it through about your size, your scaling, your options. Now, that could be some points that have gone rogue. Why is there an outside turn? That's called the skirt. What that does, it allows your 3D printer to prime itself. So before going straight into the print, you have to make sure that your nozzle's unblocked, that your plastic is flowing freely, and there's no snags in it. So what that does is that essentially generates a way of priming your nozzle. Clear any blockages, let you test that everything's working okay, and then it lets you go straight into hot plastic coming down onto the print bed. It's always advisable to do that. Yeah. It also delineates the print area to make sure that nothing else gets in that print area, and there's enough clearance to get your head down and up. Okay, so let's get rid of that just now and bring in another one. So let's bring in our broken Cobra and let's have a look at the ideas for supports. Now this may not work too well because of the scale. So what I'm going to do is I'm going to modify. No, I can't, where's my modify? Edit. I'm going to scale that model up. So I'm going to change that to 6 times the size. Yeah, there we go. Nope, don't move it. And we will save that. So all that saves us temporary file in the same folder as where this is saved. So that has now changed the scale of that model up by a shed load. Okay, so that's a lot bigger than it was. As you can see, it hasn't been overly happy with the way that it's been spliced there, so it's got a little bit of overhang. But as you can see, we need to try and sort something out about this overhang here, so that it doesn't actually just collapse onto the thing. So what we can do is we can use our settings. So we've got settings and controls and support material. Now at the moment, generate support material is off, so I'm going to switch that on. Support type is lines. Now you can change that to a grid, so instead of just doing, it'll just do vertical lines, so lines of plastic that will hold it up, or you can have a grid, so it'll do a grid pattern underneath it to hold it up. Both work just as well, depending on how you set the spacing. I have never got this to work right, but the principle is visible there. So I've put that on. pattern spacing, all those things are different things. The air gap is what's intended to be there so that you can easily break it off. So once it's all dry, just you can snap them off, and that in theory works. Okay, so let's go there. Let's go to layer view and then click generate. And there you go. So there's our model. Now, this is the model. This is the support. So you can see what I mean by using a lot of plastic. So if I grab that up, and as you can see it's starting to grow, your lines here are what are delineating your actual ship outline. All this stuff is support plastic. I'll go up through the model. As you can see, I'll tilt that round so you can see it. As you can see, all that is support. So that's very dense support in there. Now you can change that. Pattern spacing, let's see, 10mm, support percent. Leave that as it is. Increase there, X and Y distance. Let's see, 2mm. Don't take that. And then we'll generate again. Right, and as you can see there, that's more spread out. Not by much, admittedly, but we'll see. So again, our support material will build up to get to the edges of the model. Our model is then built up from there. Now, it looks a lot worse when you look at the lines on there because they're actually rendered for clarity than it does in the actual model when it's printed. You can still see those lines when they print off, but you can sand them down. There they look like sausages sitting on top of a plate. Pattern spacing, 20mm. Do that as a grid, and I'll let you see that as well. It doesn't actually look all that much different, does it? But anyway. So yeah, what you're trying to do essentially is use as little plastic as you can to get as much support as you can. And I'm just going to take that support material off. And then generate it again, so you can see the difference. So there's your outline. So that outline is only really across where it hits the actual board. So then you're going up from there. Now, as I was saying earlier, there's an infill. This is infill here. This hexagonal pattern on the inside of the model is your infill. What it's intended to do is save you plastic on models. So rather than filling up the entire model with plastic, you can actually put a pattern inside it to stop it. Density there is 25%. If I say 15% and then regenerate, you'll see these hexagons get bigger. Let's go back onto there and see it again. As you can see, much bigger hexagons, much more space inside. Now for something like this, which is essentially going to be a fairly small model that's not going to get particularly heavy handling, a percentage like 10 to 15% is fine. It's sealed in, it's not going to be a load bearing structure, it's not going to be used as a lever or anything like that, so 15% is fine. If you're going to use something like this for printing off box cutters or something that's going to support something, or you're going to print off a new stand for your chair, then 100% fill is what you need. And as you can see, what I'll show you there is with these settings on, you have all these settings up here. What they tell you is exactly what's going to happen when you print it, so how much filament you'll need and how long it's going to take. That's your main two things. So the filament length there is 2 meters, and the estimated mass of it is 6 grams. So that's 6 grams of plastic will go into that. The drum on the back of my printer at the moment is a 1 kilo drum. So that model is going to be on there 1, 2, 3, 4, 5, 6 centimeters long, or 6 centimeters wide, and about 4 deep. And it's going to be 6 grams of a kilo. So that's pretty good. If we go back and put that support material on, by the way, and then generate that again, watch that number there increase, and the print time. So that's now taken half an hour longer, an extra meter of filament, and 3 more grams with all that material on there. Obviously I've selected a grid support type and it's not actually doing it as a grid. It's still doing it as that. Never mind. Anyway, so there you go. It's that's pretty much the main thing about how to print off something with support. As I said, support I've never really got working properly. It's not something I've managed to actually get right yet. So in let's add another model. Let's put the broken halves on. So rather than using the support idea this time, we're printing off as 2 separate halves of a model. Now let's again edit that and scale it up to 6. Save that. So that is the same model but printed with a vertical shape with your flatter surface on the bottom. Okay, so as you can see, same shape, same shape. All you'll have to do is print it off and glue it together in the middle somehow. Now, gluing a model is actually a whole different trick in itself as well. There's not many of your average standard kinds of glue work well with ABS plastic, which is it ABS? No, PLA plastic, sorry. Polylactic acid. It's essentially sugar. It's a carbohydrate, organic, I think decomposable plastic. Comes in reels. It can be printed off into anything you like. It's fairly lightweight. It's quite soft in comparison to Lego, which is ABS, for example. It's quite light, and I do believe it's biodegradable. The interesting thing about it is if you burn it, which I have tried to do, it actually smells like caramelized sugar. So to me that would indicate that the easy way to get rid of this stuff is just burn it. Just melt it down and burn it and it'll be fine. Whether you could use the plastic you're using to make the print as glue, yes you can, if you can work out a way to melt it without melting the surrounding plastic. What someone did say is if you have a soldering iron, you can use a soldering iron to weld plastic in between. If you're very good at using a soldering iron, you can use that soldering iron to actually make the seam in the middle glue together. But it can be quite messy because what you're basically doing is you're melting. You have very little control over what you're melting in the middle. Now what I do have is what came with the magazines that I collected the printer from is a pack of tools, and that does have essentially a soldering iron but with a lot of tools that you can use in that soldering iron's nib, and one of them is a flat bladed knife. Now that is quite a useful tool for cutting things away, including supports, and you could use it as a flat surface to put in between the two halves that you're trying to glue together, so it'll melt both sides, and as you move this thin blade through it'll actually melt them together. If you do it, you'd have to get the right speed to do it. So using ABS you can make a glue out of bits of ABS and acetone. Interesting. Well, in terms of PLA glue, I'm trying to think. Someone told me the best thing to use. I think the only thing that actually really works, some people have said, other than actually melting it together, is super glue. So cyanoacrylate glue seems to be one of the things that does work. Or screws, little screws. So depending on the size of your model, that would work fine. So okay, let's just have a look at how this method of printing, so rather than using the supports and all that kind of stuff, or having that model as a flat model, we're looking at something on the order of an hour to print the original version, so we're not going to use support material because we don't need it in this instance. We're going to use a 15% infill. Oh no, we're going to go 25% because that was the number we looked at that gave us the hour and a bit. Let's go layer view and generate. 60 minutes, so exactly an hour. Same amount, roughly the same amount of filament, roughly the same mass. Obviously, it's the same model, but it's quicker to actually print, which is interesting. So the method that you use for putting your model into the printer in the first place can save you some time. You'll also find that depending on the orientation of your print, the amount of infill that you use and how it's used can reduce the amount of filament you have to use as well. So it's pretty cool. So there you go. I mean, there's your triangles there. And as you can see, that helps. That prints it off in a very, very nice way. Now what you can see as well is because before when we had the model, because it was lying flat, all of your layers were all being ringed, like put in big rings. So the top surface of your ship had all these rings. No, I've been told PLA doesn't work with polystyrene cement. People have used poly cement, and I can actually attribute that myself. I've tried to use poly cement from model kits on PLA, and it does not work. Just falls straight off again. I've also tried to use plastic weld, which also just falls straight off. I've also tried to use 2-part epoxy resin. That also doesn't work. And the only one I've had any luck with has been superglue. But even superglue isn't 100% stable. What I tend to do is I'll use thin sticks. I'll drill a little hole and I'll put a thin stick in. You know, the little pin vices you can get from places like Games Workshop, that sort of place. Polycement used for plexiglass. Well, that's not poly cement though, is it? That's polystyrene is meant for use on non-expanded polystyrene plastic. Plexiglass isn't polystyrene, is it? Plexiglass is something different. But if it would depend on the stuff, on the formulation of the poly cement. If it's an industrial strength one, it might work. I have heard people say good things about PVA glue, believe it or not. PVA glue apparently does a good job. You can also use something that removes the oil. If you wash it down with a degreaser, you might actually get a decent join with some certain glues as well. Gorilla Glue is one thing that people have suggested, but I haven't tried that one myself yet. So I just know that I've used 2 different types of poly cement, both for model kits, not for plexiglass, and they haven't worked. Plastic weld is a different one, also hasn't worked because it's different. Because plastic weld is meant for melting polystyrene. PVA is currently holding my pre-print parts of my polyboard. It's the oiliness that's the problem. It needs something that takes that oiliness away and that gets into the crevices and actually grips them together. That's the problem with it. That's why I think Gorilla Glue might work because it's water-based and it actually expands into the gaps and foams. I'll show you a little bit of that. So if you just look at the corner of that, that's what Gorilla Glue does. It expands out. And it works rather well. So I'm thinking about trying that at some point. But anyway, as I was saying, when you have the model flat, with the top surface pointing straight up, your layers are going around. So they're going around the top of the ship, or car, or whatever it is, and have got a slightly less resolution on that axis, so the x-axis if you like, than they do when you print it like this. So you print something like that, because your vertical motion of your head is much finer, because the head can move at 0.01 millimeters each layer. You can set the default is 0.02, but you can do it at 0.01. So you can have that degree of finesse on each layer, which makes your structure much more detailed. So you can get a lot more detail into that. So yeah, so that's 3D printing. Now I can't obviously show you what I'm going to do on the 3D printer itself. I'll save that for another session once I've got the 3D printer actually primed, and a camera that you can see on. But that's basically how it all works, people. So, I'm pretty much done. There's not a lot else I can really show you in terms of how to put a model together. I'll talk about a few of the options that you can have for 3D printing within this software. So obviously you can set all the different layer heights and so on. So as I said, there you've got 0.2. Your layer height can be as low as 0.1. And you've got all these parameter options. But I think the main thing you've got is your infill is making your model a bit more hollow to save you plastic and time. Because the more infill you have, the more plastic you fill it with, the longer it will take to print. Speed is essentially how fast it goes. Now the speed can be a factor in how accurate your model is and how quickly your plastic dries. So if you have a fan cooling system on your printer, then you have to move your head slightly faster, or else the plastic actually cools as it comes out of the nozzle and is actually slightly drying by the time it hits the previous layer. So you have to make sure that your temperatures, your filament temperature, your head speed and your ambient temperature are all very well put in. Now at the minute, I mean I'm looking at this at the minute, and on there it tells you what the ambient temperatures are. This is the extruder temperature, and that's the print bed temperature. Now they're not even switched on. They are literally just sitting in my room. So in this office at the moment it is 30 degrees, and that's how hot the bed is, which is hot for a bed. Just sitting there as a bit of plastic on its own. That's because of the ridiculous bad ventilation in this room, which is bad for the plastic as well, actually, because the warmer the plastic gets, then it starts to get imperfections and doesn't remelt properly. Now rafts, a raft, if I actually show you what that does, as it says on the little tooltip there, it creates a bed for the print to sit on. Now if you have something that's fairly thin, or it has thin bottom, like say you're printing off a frame for something and it's got like a 1mm edge around the bottom to hold it up, the chances are the bottom can spread, or the weight actually on the top could push those thin legs down. Using a raft allows you to have some more stability. Now as it says in the tooltip, it's primarily a thing about ABS. Warping prone plastics, I mean one of the reasons that PLA is so popular is it's not as prone to warping as ABS and the more brittle plastics are. I think wood filament, because you can actually get wood filament as well, is quite brittle, and again it tends to suffer under the stress. But a raft underneath, which is just it's just a grid of plastic, or a grid of plastic lines underneath your model. So I'll just show you how that works. So there you go, that's all it is. It's just a grid. If I move that up and you'll see where it goes. So there you go, you've got a grid of like 3 layers or 4 layers. Dear me. On the first layer. Now it works the same way as support does, so it's the same pattern as the supports, but it just holds your initial layers so that you can easily lift it. The only thing you'll have to do is you'll have to make sure that you've got an easy way to lift it off, because the raft again attaches directly to the model, so you'll have to sand that off. I've seen people break a raft away with no issue, but that's only if they're not fussed about the bottom edge of the model. And in this case, you've got the bottom edge is one you want to actually try and stick together with this particular model, for example. So you'd have a rough surface that you'd have to try and sort out from there. So yeah, that's that part of it. Output options, nothing much there. You have options in there, that's more for the more advanced printer, if you like. Your filament options there, again, PLA tends to be 207, between 200 and 210 is the ideal temperature for it. Otherwise you get stringing. Your bed temperature, the hotter the bed is, the better the adhesion, but the more likely you are to get spreading, or what we call elephant feet, as your plastic melts onto the thing. What I tend to do is I cover my print plate with sticky tape, with masking tape, because it provides a sticky environment for it to stick onto, and it means that you can get it off. You can get your model off the off the print plate. Because one of the mistakes I made initially was doing straight onto the print plate. Sometimes, especially with smaller models, you can't get the model off the print plate. So if you print something thin, I mean, I was printing off little tokens that are meant to be for Fantasticon, and they were stuck fast to the plate. Could not get them off. I had to eventually get a screwdriver and lever them off, which actually damaged the print, damaged the plastic itself, and damaged the print plate. I then bought a sticky thing, a layer of material that I could put on top of the print plate, which was supposed to improve the adhesion but allow you to take them off. It was crap. It was worse than the print plate. It was like glue. The adhesion was fantastic, but there was no way to actually flex it enough to get the print off. And again, if it was something small, no chance. If it was something tall, you'd be lucky. So yeah, the best option I've actually had so far is masking tape, blue masking tape on the print plate. A temperature of about 50 degrees, maybe 70 degrees depending on what it is you're doing, and it's just enough to give you that kind of that ability to have it stick to the plate and get it off the plate as well. So retraction is the removal of the head while you're moving the print head from point to point. So if you're not actually laying down plastic, the idea is that as it's laying down plastic, when it's not laying it down, like if it's jumping from on the screen from there to do another layer, so it'll do each layer on each level, on each model. So you're coming up and then across and then down again. That's what the retraction thing is. It also retracts the head actually retracts the plastic inside as well. So if you imagine that being your head, your plastic is coming out here, which is looking a bit rude. Then when it's blobs it all out, when it's moving, it'll retract the plastic back in so it doesn't rip as well. So all the settings for that are there. Extrusion, again, that's just how it takes out the plastic from the spool. And your cooling fan. Now I don't have the cooling fan fit to mine because I didn't bother putting it on, but I'm going to at some point, although blowing hot air around here probably isn't the greatest idea. But that's all it is. It's just how you keep the thing cool. I've had mixed reports about what the cooling thing does. Now, some people say that it's best to actually cool the model as it's printing, and some people say that cooling the model as it's printing means that your next layer doesn't stick as well, because you lose all the tackiness of the previous layer if it's cooled down already. I don't know. Your mileage may vary. That's for you to decide if you want to do 3D printing. I'm using a glass sheet on the print plate and using a high hole hairspray. Yeah, see, I've thought about this glass sheet thing, and I've heard that hairspray is a very good idea. But glass sheet, I don't like the idea of the glass sheet, because I tend to flex my print plate when I'm trying to get stuff off it. So it does have a little bit of bend in this one. I had to put something on this one anyway, because this print plate is crap. Look, it's got little dots in it. It's got little holes. When you print something off, you get this little dotty hole texture all over it, little pins all over it. It's nice in some ways, because when I did that 3D printed Lego gun, the first two bits I printed off were the main shell, and because they'd obviously sat on, like, with their external side on the print plate, they had this dippled texture, which actually was quite nice. So, no 3D modelly things actually around here to show you, unfortunately. Have I got anything in here? Yes, I do, but it's not very good to see. Right, there's something, and there's something. Okay, so a couple of things that I've actually printed off. Now, one of the tests I've done is a dice, again, poker-sized dice. There. What I'll do is I'll actually pop open the bigger window. So let's do the desk recording window. There we go. There's a bigger me. Well, let's go for that one. It's got decorative background on it. So yeah, that's a dice design that I came up with for testing. It's a game idea as well. Don't nick it off me. So that's how it prints off a dice. As you can see, each side, because you only have a little bit of indent on each side, it printed off okay. That side, he says trying to rotate it properly with it being backwards. Right, that side was the side that was on the print plate. Have you printed the Marvin keychain? And if so, how did it come out? What Marvin keychain? No, I haven't, is a quick answer. This is a stand for a keyboard or a tablet. I have two of these, but it's primarily for putting my keyboard on when I'm not using it. Use it for anything you like. You can use it for a hard drive, you could use it for an iPad, you could use it for anything you like, really. But that's the idea. Print it off on its side. So print it off on the side like that. Marvin keychain. Alright, let's have a look for the Marvin keychain then. Thingiverse. 3D Hubs Marvin. Nice. Interesting. T. Come on, today. Design. 3D models. Thingiverse. Show in folder. .3D hubs. Extract to there. Remove. Add. 3D models. Thingiverse. 3D hubs Marvin. See. So this might be printed without supports, so it looks like it would be a bit problematic. So I don't know how that would print. The loop on the head was awful. See, that's the benefit, is that obviously it's things that are hanging in space like that, because that's quite a high angle. I mean, that's about 45-degree angle, so it's about the limit of what you're going to get. But if cooling obviously would help it cool on the way out of the nozzle, so it wouldn't drip as much. So that would be feasible then. I'm just blowing it. That's a cute little keyring, that. I like that. I might have a go printing that. Okay, and lastly, I showed you the castle design thing earlier. This is how it printed off. So that's the little castle template thing that we had. That printed off. And to be honest, the texturing from the 3D print method actually makes that look bloody good. So that's a few things. Yeah, I quite like that little keyring thing. The ears were a little bit teardrop shaped rather than round. Yeah, I think it's small enough to be able to give it a go without supports, to be honest. So in that bit in there, that bit in between his legs, that might be workable. That's the only bit I would really worry about, and obviously that bit there, as long as you're not going too hot, you shouldn't droop too much. And obviously you've got the eyes there. Again, the size It's what dictates it, because that's the main thing about the 3D printing world, is the weight obviously drags it down. The smaller the model, the easier you can do going left to right or up and down, without getting droop, sag, stringing, etc. I mean, if that was twice the size, I don't think that bit across there or that loop would be able to support its own weight as you're printing it. But yeah, it's a cute little model, I like that. Oh dear. It's quite a good test piece for setting up printer nozzle temperature to eye. Yeah, that's been my issue. Obviously the temperatures I've got set now, 207, is about right for my environment. Last time I did some printing was in the winter. So I'm actually thinking that might be a little high at the minute, or it might actually stabilise slightly. I don't know. I'd have to try it again. It's been a long while since I've not printed now. I've not done any 3D printing now for about 6 months. But now that I've dug it out, I'm going to do something on it. But I can't say what, because I give something away and I don't want to do that. But yeah. So I'm actually going to play with that Sidewinder model and actually see if I can print something off from that, because I'm quite pleased how that came out. So that was 3D printing. I'm pretty much done on that. Not a lot else really to do. I'm going to close my windows down for the printing stuff at the moment, and I hope you've enjoyed that. But this was my first attempt at doing a creative stream. I'm a bit sad I didn't get more viewers. Not great. But obviously we're just trying to build this stream up at the moment, so I'm not going to think too much about it just now. Well, obviously the YouTube stuff's there as well. So this will be on YouTube as of later on tonight. If you enjoyed it or you want to do anything more about 3D printing, then let me know. And we'll see where we go from there. Next week, I believe we're doing, I think it's the transport one. Games Workshop Primer. Yes, that's very true. Any primer would be good, but Games Workshop Primer does stick to a lot of things rather well. Again, though, you'd have to make sure you scrub it with some kind of degreaser. Paints on these things tend to be a little bit kind of weird. I tried to paint them. I actually got a painting pen, which worked quite well. Now, where is it? I saw it earlier on today. Typically enough, it'll have gone missing. Yeah, I'm not going to rustle around like an idiot for it. It's there somewhere, I'll turn it. But yeah, I got a painting pen, which is quite good. So we'll be looking at the new update for No Man's Sky. It's not the week for space stuff. That's the first week of the month. But that, unless I do a random unplanned stream, I'm planning on looking at No Man's Sky's update on the first, on the space day, which is the first Wednesday next month. So that'll be about 2 weeks time, 3 weeks time, 2 weeks time. Because this is the third week, next week's the fourth week. Yeah, so it'll be the week after next, I'll take a look at it, yeah. That's the plan anyway. But again, I might take an unplanned look at some point. It's 26th that comes out, isn't it? If I remember rightly. Yeah, so we'll see. Next week's theme is 24th. Okay. Next week's theme is transportation. So that's usually things like driving games, truck simulator, racing games, that kind of stuff, flight sims, and so on. I suppose technically No Man's Sky is a transport game because it's spaceships. We could probably wedge it in there, but we'll see. But yeah, so we'll see. I don't know what we're going to do yet. I'll take suggestions. No Man's Sky is one option. If there's an update that makes it worthwhile doing, then we'll take a look. But I was going to leave that until the week after. But you know what? Let's see what happens. Start a poll on Facebook or something and see where we go. As I just said, Garzini, week 4 subject is transport. Check on the website. daftworks.co.uk/Selezen. But yes, so I hope you've enjoyed this. I've quite enjoyed having a bit of a look. I hope it's been educational. I hope you get into 3D printing because it is a fun thing to do. I know that Garzini, you're already into it, so that's fine. You can pick up a decent 3D printer now for about 300 quid, if not less, for a slightly less decent one. But they are tumbling down in price now. I mean, they're practically becoming household items at the moment. Again, bear in mind you do get what you pay for. The customizability, the drivers, the functionality, and the quality of the output, and obviously the maintainability of the printer may not be as great for the cheaper prices. So I would tend to recommend still staying with the mid-range price range, so that's about 700 quid to 1,000 to get something decent that's going to last you a while and be able to print something that's going to be usable. If you really want to get into it in a big scale, yeah, see what I mean? They come tumbling down. You want something that's really decent and it's going to do you quite a lot of stuff, then go for sort of the post £1,000 range, and you'll get something that will hopefully give you commercial quality output that you could actually sell. Obviously, the more you spend, the better the kit, the better the nozzles, the better the quality. Therefore, the smaller the model you can print at a decent resolution. Obviously, the smaller you get, obviously the more detail you lose. I mean, looking at that as a dice, it's fine, but as you can see, you get quite a lot of banding and lines on it, and that's the price you pay for the lower range printers. On a £100 to £200 printer, I'm not entirely sure if that would be any worse than that, but I don't know. Garzini could probably answer that one. But all I know is that, I mean, I printed that off, and you can actually see the detail on there. I don't know if you can see it because of the camera resolution and the fact it won't fucking focus. But brickwork is visible on there, so that's quite impressive. And just that'll show you how thin you can print on it. The crenellations at the top there are essentially 0.5 millimetre thick, which is quite impressive. So, indeed, we are done. Set yourself heady task for PC upgrade. I want to get some M2 SSD. Ooh. Means a new mobile and of course new CPU. Oh, that means new RAM. Yeah, it's a snowball effect. I hate PCs. Hate the upgrade thing. I've obviously had to go through the upgrade thing in March because of things not working properly and wanting to upgrade, and even then getting the Oculus Rift and discovering I had to upgrade the graphics card to be able to use the bloody Oculus Rift. Yes. But as I say, if it's something you want to get into, then I can give you some advice on that. Anybody who's watching this video, if you're interested in the 3D printing and you want a chat about it, or you want me to do more videos on this kind of thing, then by all means drop me a like or a follow, or drop me a comment. Grab me on Twitter, grab me on Facebook, whatever, and we can have a chat and see what you want to do next. I'm open to ideas. Again, this is a new idea for streaming for me, a new subject, a new topic. And if it's something that's popular, then obviously I want to do more of this kind of stuff and take it on. Next time I do a creative stream, it might be something a bit different. I might do video editing, I might do graphic design, I might do something else. Or grab me at Fantasticon. But then I'll be doing another one of these before then. Yeah, because there'll be the third Wednesday in August. One of these. So, yeah. So anyway, I'm going to head off. I hope you've had a great time. I'm just going to go into my stream intro now. I hope you've had a good time. I hope you enjoyed the stream. I shall be, hopefully, if nothing goes wrong, streaming on Sunday afternoon, UK time, at about 3 o'clock. It usually is a little bit later than 3 o'clock because we do tend to faff around quite a lot at the start of the stream. For the Elite Encounters RPG, this will be the Ascended Part 9. As we continue our voyage across the galaxy and our encounter with our own space station at the moment. So hopefully see you then. If that doesn't happen, I'll be back here again on Wednesday at 8 PM with the transport themed stream. Which, you know what, you've got me tempted, Grum. You've got me tempted now to want to do the No Man's Sky thing. But we'll see. We'll see how things go. So, take care of yourselves everyone. I hope you've had a great time. and I'll see you on the flip side. Fly safe and have a great week.